In solving a separable differential equation, you try to separate x terms and y terms, and then take the integral. For example, in solving 1 plus x dy minus y dx equal to 0, first, we're going to separate these two parts by writing 1 plus x dy equals to y dx. So far, we have 1 plus x dy, and on the other side, you have y dx. It's not quite the same as what you have in general form. What are we going to do? We're going to divide both sides by 1 plus x times y. When you do that, when you divide 1 plus x dy by 1 plus x times y, you end up with dy over y. And when you divide y dx by 1 plus xy, you can cancel out y, and you end up with dx divided by 1 plus x. These two are equal to each other. Now, you see that we have a separable differential equation. You can start taking the integral of both sides. So the integral of dy over y must be equal to the integral of dx over 1 plus x. Now we're going back to calculus. How do we take the integral of dy divided by y and the integral of dx over 1 plus x? Remember u substitution. The integral of du divided by u is ln of absolute value of u plus constant of integration. So on the left-hand side, we have ln of absolute value of y. And on the right-hand side, you get ln of absolute value of 1 plus x. But remember that you need a constant of integration as well. So let us add that. Now, for C1, which is a constant of integration, you can use C, K, any constant that you like. It doesn't have to be exactly C1. Now we're going to use algebra. Try to solve this equation. Remember that if ln of f is equal to ln of g plus a numerical value, then by the properties of ln, f of x can be written as the exponential function e to power ln of gx plus c. Everything goes on the exponent of the exponential function. So the absolute value of y on the left-hand side is equal to e raised to power ln of absolute value of 1 plus x plus c1. So you take the whole term and you leave it in the exponential form. Well, it says, hey, e has the addition of two exponents. What's the meaning of that? It means that we can separate these two exponents and write e as e to power ln of absolute value of 1 plus x times e to power c1. This is equal to the absolute value of 1 plus x times e to power c1. Why is that? Because e and ln, they get canceled out. E and ln disappear, you end up with absolute value of t in general, or if you have e to power ln of x plus 1, it is x plus 1. So again, e and ln, by the properties of ln, they cancel out. So far, we have y equals to plus minus e to power c1 times 1 plus x. Since you have the absolute value of y equals to the absolute value of 1 plus x e to power c1, to get rid of this absolute value, you need to add plus minus in front of either y or in front of the quantity on the right-hand side. But take a look. Here you have plus minus e to power c1. This is another constant. We can relabel this. We can rename this, for example, to be c or k. Relabeling plus minus e to power c1 as c, you can rewrite your solution as y equals to c times 1 plus x. So the solution for this differential equation, separable differential equation, is family of lines. Okay, perfect. Let's take a look at our visualization. if we try to visualize the solution for this differential equation, these are basically a bunch of lines or a family of lines. When C is changing, your family of line has different slope. So when C is positive, you get a positive slope, you get increasing lines. And when C is negative, you get decreasing lines. So that's how we visualize the solution for differential equation. There are many websites that you can use. Just look for visualizing ODE or grapher ODE.